Hello friends, have you ever wondered where apps or games on your computer store your data? In real life, when we store something, we use different containers for different things. For example, if we want to store sugar at home, we keep it in a jar, and if we want to store water, we use a bucket. If the quantity of water is large, we store it in a tank. Similarly, in programming, we use different data types to store different types of data. And in this video, I will explain all the data types and how they are used when developing games. Let's start by understanding the basics. The definition of a data type is, a data type specifies a type of data that a variable can store, such as an integer, a float, or a character. To explain in simple terms, a data type defines what kind of data a variable will store and its size. In C#, there are different data types to store different types of data, and each data type stores specific kinds of values. The memory size of these data types also varies. In real life, different items are stored in different containers, like sugar in a jar, water in a bucket, or large quantities of water in a tank. Similarly, in programming, the type of container or data type depends not only on the type of data, but also on its quantity. The same logic applies in programming. In C#, to store numbers, we commonly use 6 types of data types: int, long, uint, ushort, float, and double. Let's first discuss which of these data types store integer values. If you don't know, integers are whole numbers without decimals, like 1, 10, 50, 20, and 1000. To store integers, we use int, long, uint, and ushort. I'll explain the differences between these data types, as they all store integers but differ in size and range. The int data type, for example, stores numbers within a certain range and occupies 4 bytes of memory. It can store both positive and negative numbers. If you need to store larger numbers, you can use the long data type, which has a greater range than int. As I mentioned earlier, just like we use a bucket for small amounts of water and a tank for larger amounts, we use int for smaller ranges and long for larger ranges. Both int and long store integers, but the difference lies in their size and range. You can see on your screen the range of values that int and long can store. Additionally, there are other data types with specific ranges, which you can view in the table provided. You'll also see the size of each data type in memory. Signed data types, like int, can store both positive and negative numbers. These distinctions were very important in the past when hardware was less advanced, and memory had to be used carefully. Nowadays, we mostly use int, and long is used only in rare cases. Remember, if you don't need a large range, it's better to use int because it consumes less memory. Now, let's look at some code. I'll create a new file in Unity and name it datatype example. Before diving into syntax, let's understand how to name variables in programming. Naming conventions are used to maintain consistency. We'll look at 2 types of naming conventions: Pascal case and camel case. In Pascal case, the first letter of every word is capitalized, with no spaces or symbols between words. For example, if you want to write my age in Pascal case, both M and A will be capitalized. In camel case, the first word begins with a lowercase letter, and the first letter of the second word is capitalized. For example, my age has a lowercase m and an uppercase A. Different naming conventions are used for different elements in coding. For example, methods are written in Pascal case, while variables are mostly written in camel case. Consistency is key. If you use one naming convention in your code, stick to it to avoid confusion. Also, remember that variable names should not have spaces, as that will cause errors. Let's write the basic syntax for a data type. On your screen, you can see I've written private in Indian population. Here, private is an access modifier, which we'll discuss in detail in a future video. The int is the data type, and Indian population is the variable that stores a number. For example, if we store India's population in this variable, and we want to store the world population in another variable, we'll create another variable like this: private long world population equals 8_000_000_000. Since the world population is a large number, we use the long data type. I've also printed both values, and as you can see on the console, India's population and the world population are displayed. If you don't want to initialize a variable immediately, you can leave it uninitialized and assign a value later. For example, you can write in Indian population and assign a value to it later in the code. This will work just fine. We'll dive deeper into this when we discuss memory allocation and how values are stored. For now, I hope the syntax is clear. Remember, C# is case sensitive, so write variable names exactly as defined. Next, let's talk about storing decimal numbers. Sometimes, we need to store values like an object's weight or height. For such cases, we use data types like float and double, which can store decimal values. For example, float can store up to 7 digits after the decimal point. If you need to store more precise values, such as the radius of a circle, e.g. 5.123456778, you can use double. I'll show you both in code. We write float number equals 3.14159f to store a float value. If we we need greater precision, we use double, like this. Double radius equals 5.123456789012345. A double can store up to 15 to 16 digits after the decimal point, but it uses more memory, specifically 8 bytes. Now that we've covered numeric data types, let's move on to storing text data. To store a single character, we use the Char data type. It can store any single character, be it a letter, symbol, or number. However, if you store a number in Char, it will treat it as a text character. It uses 2 bytes of memory. For example, private char grade equals stores a single character. Always enclose the value in single quotes. If you need to store a sequence of characters, like a word or sentence, use the string data type. For example, string my name equals gamer stores the word gamer in the variable my name. Always enclose string values in double quotes. The memory used by a string depends on the number of characters. It dynamically allocates memory based on the text length, allowing you to store any size of text. Finally, let's discuss the Boolean Datatype, which is unique because it only stores 2 possible values, true or false. We use bool for decision-making or logical operations in programming. For example, bool is greater equals 35 greater than 12. We'll store true because 35 is greater than 12. It uses 1 byte of memory. We've now covered several data types. These can be grouped into primitive and non-primitive data types. Primitive data types are predefined with fixed sizes like int 4 bytes and bool 1 byte. Non-primitive data types like string have dynamic sizes based on the stored value. In future videos, we'll discuss classes and enums, which are also non-primitive types. For today, I've explained the basics of data types, which we'll frequently use going forward. As we progress, we'll explore more data types as needed. See you in the next video.